of this with first part with a little bit on qualitative deflected shape. So I'm sharing you now the slide on. This is already uploaded on the e-learning. Qualitative deflected shape is a concept. It's a kind of a diagram, or also we call it elastic curve. Okay, and it is a sketch of the neutral surface. Let's look at we give a definition to that. In the deformed position under the action of a given loading conditions. And it is qualitative, class, meaning that we do not, the diagram do not actually show what is the actual deflection that happened, but is only the shape of the deflection which is important. So it is a very exaggerated sketch. But the important information is how the beam should bend. It bend up or bend down, and where it shouldn't bend and where it shouldn't move. So that is the most important information. Okay, so qualitative deflected shape, for example, this is a meaning of qualitative deflected shape here. So this is a beam, okay, then supported here and fixed here, supported by the roller support. This is the original positions. Then under loading, this beam will bend. So the dotted line here shows the deflected shape. This beam will bend down, bend up like this, but here because of the support, it will not move. And then down here, then it will move, bend down, and then because of the support here, it cannot move and it cannot, the rotation is zero. So the importance of able to draw this qualitative deflected shape is we can get good information about the behavior of the structures. So how is it going to bend? Okay, and it is sometimes important to know this so that we can make important design decisions when we know how the beams, how the structure will deflect. So, and then also, if you are able to sketch this, then it will be a good guide for us when we want to do numerical calculations of the deflections. So qualitative here does not represent the actual value. Okay, it only because it is exaggerated. The beam does not deflect so much like this, but this is exaggerations. But we have to draw it in this way to show the curvature. How does it going to curve? Curve up, curve down. Okay, those are the main important informations. So this, of course, this represent this line here represent the neutral axis of the beam, and then this one represent the deflected shape. Okay, and the sketching of this qualitative deflected shape is based on bending moment diagram and understanding of what is the meaning of positive bending moment, negative bending moment, and also the other important information is support conditions. Whether it is fixed, it is pin, or it is roller, or it is a cantilever beam. And it is very important ability that I think all students should acquire, okay? Because this is a very important skill. As an engineer later on, we must have this skill able to sketch the qualitative deflected shape and to see whether the behavior is reasonable or not based on the calculated result. Okay, so from there we can check also whether calculation is reasonable or not. Okay, especially when we are using a lot of computers, then we can check the information has been input correctly, because computer program normally they will not tell you, excuse me, you have input wrongly, you have input some value wrongly, please recheck again. Computer at this moment does not tell you that yet. Maybe in the future with artificial intelligence, maybe computer has that intelligence. Okay, they will tell you, excuse me, remember EAS253, this part I think something wrong. Okay. At this moment, computer program is not able to do that yet. Okay. So this skill comes back to us, able to feel how the beams is going to deflect, whether it is reasonable or not. So bending moment diagram, we have as one example here, bending moment diagram. There are positive bending moment and negative bending moment in the bending moment diagram. So we must be able to relate to what is the meaning of the positive bending moment and negative bending moment in terms of how the beams at that particular part is going to bend. Is it going to bend up, bend down? So is it a sagging moment or bending or hogging moment? So that is important things that we have to be able to understand clearly so that we can draw qualitative deflected shape correctly. The second thing which is equally also important is support conditions, and what does that mean of that particular support? No rotations, zero rotation, zero deflections, or only zero deflection but rotation is free. So those comes back to our understanding of what kind of deflections is restrained. Okay, what kind of movement is restrained. Okay, fixed rotation is restrained, displacement also, translation also restrained. Pin support, only translation up down is restrained, rotation is not restrained. So those are the things that we need to recall and then apply when we draw qualitative deflected shape. Example, I think very simple example. I think the bending moment diagram, by now, I think if I give you a beam, a problem like this, a simply supported beam with a point load at the center, so immediately you should be able to know that if I give you that this is symmetry, 10 kilonewton, immediately this one is phi and phi, you should be able to know. And then immediately you should be able to come up with the shear force diagram. It should be like this, and bending moment diagram should be like this. Now for qualitative deflected shape, we make use of bending moment diagram, which is like this and all the way positive. Magnitude changes, but all the way positive from A to B. So positive bending moment means it will bend down like this with the top part, the top portion of this, the top fiber of this, we call it the top fiber of this in compressions. Yeah, in compressions. So that is the important understanding, and the support condition here, this is pin, this is roller, so not moving here, is not allowed to move, so it should stay at the same point here. When we draw, it should stay at the same point. Okay, that is an important part. So cantilever, I think sometimes just want to share with you. Sometimes I think when your senior go for job interview, some engineer, they want to test the understanding. Okay, test the understanding. So they ask you, they give you a cantilever and then with a point load, and please sketch for me what is the shear force diagram look like and bending moment diagram without doing any calculations. So you should be able to draw that. Now I'm giving you some tips. This is soalan bocor when you go for job interview, which is maybe 2 or 3 years from now. So already get ready. They might ask you these questions. Sketch the bending moment diagram. So if it's a point load, then bending moment should be a straight line, maximum here, and if it's a cantilever, maximum happen at the support. If it's P, this is L, it should be TL. You should be able to get that fast, I think, as a feeling of this. Okay, so now we look at the bending moment diagram negative, all the way from free end until fixed support here negative. So negative means it should bend like this. It is a hogging moment. This is hogging moment. So hog, yeah. So now we have sagging. This is hogging negative, hogging moment. Sorry, this is hogging moment. So hogging moments mean it is going to be bend in this way. It is bending in that way. And the bottom fiber is in compressions, and top fiber is in tension. So bending moment negative means it is the beam bent in this way. So this is a qualitative deflected shape. Again, the support here, this is a fixed support, not able to move up and down, no translation and no rotations. Okay. So those are examples. So the important thing is important to know the meaning of positive and negative bending moment, and this is where we goes back to our convention that we agree. We sign the agreement, so we make use of this as far as we're talking about positive bending moment and negative bending moment is concerned. So positive bending moment meaning that it is sagging, is sag It is a sagging moment, so it is producing deformation in this way. The top fiber here is in compression, the bottom fiber here is in tension. Okay? And negative opposite to this, so instead of top portion, top fiber compression, bottom fiber is in compression. So the meaning of this dotted here is to indicate this part here, this fiber part is in compression. So important to understand that, class, so that we are able to draw correctly the qualitative deflected shape, and at the same time try to recall back what is the meaning of different support condition in terms of restraint. Fixed support cannot move, no translation, no rotation, so the point should stay the same here, and the rotation here should be 0. Rotation here should be 0. So here, so we reflect here. Here is a fixed support, so not able to translate up and down. So the points stay the same here. Rotation 0. So this slope here should be 0. Then only it can bend. Here, roller support not able to translate, so it should stay at the same point. But rotation is free, so it's able to rotate freely. So that is very important to recall this. Now, example, we have a bending moment diagram like this. So now these are negative bending moment, positive bending moment, negative bending moment. This is a fixed support. This is a roller support. So the qualitative deflected shape will be, because this is fixed, so not able to translate, not able to rotate. So it starts like this. Here, negative means it has to bend up until here, change to positive, so bend up until here, then bend down like this, up all the way until here, then it changed negative all the way there, so it bend up again until C. And at point B, take note that at point B is a support, is a roller support, so the point should be at the same positions because this point is not allowed to move up and down. The sign convention that we have been adopting until now, class, when we draw our bending moment diagram, is we draw on the compression side. Our positive bending moment means, if we draw positive bending moment means this side, this side of the beam, this side of the beam, because when we cut through the beam here, the beam normally looks like this, okay? Only then we draw using one line, but it has a section like this. So we draw on the compression side. The convention that we adopt here when we draw the bending moment, positive bending moment means sagging, negative moment means hogging, and positive we draw it on the top side, negative we draw on the bottom side. This is called drawing on the compression side. So when you look at the bending moment diagram, if you have positive here, meaning that the top part, the top fiber is in compressions. If you get negative like this, negative like this, so it means that the bottom part is in compressions. Okay, bottom part is in compression. We draw on the compression side. This is what we draw on the compression side. So the side that you see the bending moment diagram appear, that side is in compression. So this top side is in compression here because you draw the bottom part here, the bottom part is in compressions. So this is the way it's going to deflect. So there are different ways of drawing bending moment diagram, but we draw, the one that we use is we draw on the compression side. Okay, we draw it on the compression side. So now one example, if we have a shear force diagram like this, we have a bending moment diagram like this for this simply supported beam subjected to a triangular load somewhere in the middle here. So this is a bending moment diagram. So the magnitude are all different, but they are all positive. These are all positive. Yeah, okay, these are all positive. So when we draw the qualitative deflected shape, it will be all the way bending. Yeah, bending like this, bending like this, bending like this, because these are all positive bending moment. So now let's see how many of you now. Okay, 73. So getting more. Maybe some of you have something to do, so join a bit later. So good evening or good night. Good evening to all again who have just joined. Okay, so now, okay. So later on, when we look at frame example, also we with our understanding that the qualitative deflected shape, and with our understanding that the bending moment that we draw is drawn on the compression side, so we are able to sketch how the frame is going to deform. So this is a bending moment diagram, and it is drawn on the compression side. So this member here has to deform in such a way that this side here is in compression. Okay? This side here is in compression. This inclined member also, this bottom side is in compression. So that is the meaning of this bending moment diagram. Okay, so with that understanding, then we are able to draw the qualitative deflected shape based on this and based on also the support conditions. This is a cantilever frame, so it is fixed supported here. So with that understanding, then we are able to draw. Okay, it has to deflect in this way, so that this side here is in compressions. And when drawing frame later on, when we go through example, it is very important to note that you have to keep this angle here. This is a rigid joint. Rigid joint meaning that the angle of this joint must be maintained. So before and after, this particular relative angle, the angle here between this member at this particular joint here must be maintained. Okay, so this is another way that we need to take note of, especially when we want to draw the qualitative deflected shape of a frame. Okay, so that is a bit the things that I would like to first cover on qualitative deflected shape, and it is important to know what